Don't hold me back anymore. 3.3 Inequalities. So the last chapter we visited inequalities, graphing them. This chapter we're going to continue to do inequalities, but we're going to graph like systems of inequalities. And so let's go ahead and do a few examples. All right, let's go ahead and graph this system of inequalities. We're going to graph the top line first, just because it's on top. It is in standard form. When it's in standard form, I usually like to just do the cover-up method and find the x and the y-intercepts. I know you guys like to change it to slope-intercept form and then look for the y-intercept and the slope. Either way is perfectly fine as long as you can graph it correctly, whatever is easiest for you. So my cover-up method, I cover up the y, and then solve the x in my head, divide both sides by 2. I have x is equal to 2. There's my x-intercept. And then I'm going to go ahead and cover up the y now, the x now. And it turns out that y-intercept is equal to 4. Okay, from there I can draw in my line. It is a dotted line because of this symbol, greater than. It is not equal to, so that's why it's a dotted line. Okay, so there's our line. But with inequalities, you have to remember that you have to shade as well. So we have to decide, do I have to shade above that line or below that line, or to the right or to the left? Okay, and so the way we do that is, again, we pick a test point. Usually I pick 0, 0. And then I test to see if that point works or not. So I plug 0 into the x, 0 into the y, and I get 0 is greater than 4. Obviously, that is not true. So when it's not true, do not shade on it. Shade on the other side. In this case, we'll shade on this side. All right. And there's our graph of the first equation. Let's go ahead and do the second equation now. We'll try to do, I don't know, like a blue. We'll do a blue for the second line. All right, the second one is in slope-intercept form. So we can go ahead and start by graphing in the y-intercept at 2. The slope means up 5 over 1. Up 5 over 1. And here's our line. It is a solid line because of this symbol. It has that equals in it, so it's solid. Now we have to decide where to shade. Again, you can try 0, 0. But if you notice how 0, 0 is super close to our line, you can still test it. It still should work. But I'm more comfortable with testing a point that's way far away from the line. So I'm just trying to show you that you can actually choose any testing point you want. It doesn't always have to be 0, 0. What if I chose 4, 1 as a testing point? Let's see if 4, 1 works. If I put 4 into the x and 1 into the y, I get 1 is less than or equal to 18. Is that true or not true? That is true, which means I am going to shade on my testing point side, this one. Okay, now since this is a system, I am mostly concerned about where both graphs overlap. So the overlapping part is what I need the most. Now my graph is a little bit messy, so I'm going to erase everything and then remember where they overlap. And it looks like they overlap in starting, I'll use purple, here, here, and then everywhere over here. All right, so that's where they both overlapped. Okay, and that is our answer. Let's do another one. Another system of inequalities. The first one looks weird because it looks like it's missing stuff, but it's just y is less than 3. Remember, graphs that are in the form of y equals or y something, those are always horizontal lines. So y is less than 3 is just a horizontal line at 3. It is a dotted line, and then we have to decide where to shade. I'm going to go back to my 0, 0, check it out. If I plug in 0 in here, I get 0 is less than 3, which is always true. So I'm going to shade where it's true, underneath that line. Okay, and that's it. Let's graph the second one now. We'll use green. This one is an absolute value graph. I hope you guys remember that from the last chapter. Absolute value graphs look like the letter V. Okay, and so to help you graph this, the one that's inside, that means it moves to the left one, and then this -5 means it goes down 5. So from the origin, go left 1 and down 5. And then finally this 2 is the slope. Up 2 over 1, up 2 over 1 on either side. Let's see what that looks like. There it is. I went over to the left 1 and then down 5. And then the slope of each of those lines is up 1 over 2. Now let's go ahead and use another testing point. I'm going to test 0, 0 again, just because 0, 0 is nice and it's not close to anything. So when I plug 0 into here and 0 into here, I get 0 is greater than -3. And then that should be true to you guys because 0 is bigger than -3. So I'm going to shade where the 0, 0 is. All inside there. But again, because this is a system, we only care about where they overlap. And so if I erase everything and only color in where they overlap, it's actually this, oh, not out there, in this triangle right here. Okay, so again, that's where they overlap, so that's where I'm going to shade. Let's go ahead and do one last present for the day. We're going backwards. What if I give you the graph and you have to come up with the inequalities? Not too bad to do. It's a little tricky, but not too bad. Let's start off with this red line. The red line is a vertical line straight up and down. Hopefully you guys remember that when you have a line that goes straight up and down, it is just x equals. Remember, y equals, x equals. In this case, x equals 7. All right, but it is not an equal sign because we have shading involved. Notice there is red shade on the right of the line. And so now we have to change this equal sign to an inequality. But which one? Do we put less than or equal to, greater than or equal to? This is how you do it. You still can test 0, 0. Here's 0, 0. When I plug 0 into here, I want the inequality to show something that is false. Notice the shading is on this side, and because the shading is on this side, that means 0, 0 is false. So what symbol will make this false. 0 is greater than or equal to 7 is the false. All right, and so we're going to use greater than or equal to 7. So there's our first inequality. Let's go ahead and do our second inequality. Oh, I already wrote it down. There it is. It's the blue line. And the way you look at it is the y-intercept is 6. And then it looks like you're going down 2 and then over 3. Down 2 and over 3 gives you that slope. So there it is. There's our equation. But again, there's shading involved. So when there's shading involved, we have to change this equal sign to an inequality. Let's test 0, 0. Must be red. Here's 0, 0. We want 0, 0 to be true in this case because notice the shading is in 0, 0. So we want our inequality to be true. So what would make, when you plug in 0 here and 0 here, what would make the inequality true? 0 is less than or equal to 6. This will make the 0, 0 true, so the symbol we're going to use is less than or equal to in place of the equal sign. There it is. The only thing you need is to do a fancy squiggly line to call it a system, and there we have it. We've written the inequalities to that messy system on the left. Okay, that's all we got. Go ahead and try the homework.